Okay, you can hear me, I guess. Well, welcome to our presentation about how we're going to do progressive web apps with micro frontends. Thank you for coming. Okay, let's start. First, some words about our sponsors and the sponsors of this conference here. We are very grateful for giving us this opportunity to present our experience in front of you. So, thank you for everyone involved. Okay, so first a bit about myself. I've been in the IT industry for almost 9 years, and the first 6 of them I was a full stack developer, and I spent most of my time writing in .NET, and as you can see, Vanilla.js, Angular, React, Knockout.js, and then, yeah, everything basically. You can find me on LinkedIn if you want. And yeah, Tish will explain a bit about herself. Yeah?
Hello, my name is Tihomira, or for short Tish. I'm a software developer for more than 6 years now, and I have experience with different JavaScript frameworks and vanilla JavaScript. Currently, I'm in Ukraine for more than 3 years, and this year I stepped into software engineering team lead role, and I'm responsible for growing and building cross-functional teams.
Okay, so we have to say some words about our the company we work in. It's called Cloud Technology. It's an amazing place, which is very innovative and very fast-paced, and generally this lecture would not be possible without it, because it provides a very safe place where we can experiment and try out new things. We have a booth in the corridor, so you can check us out, and we give out Legos. So, okay.
There's a very interesting game there. You can try it out.
Okay. So, what's our agenda?
Okay, so today we're going to talk about PWA, progressive web apps. We have a little bit of theory. We're going to share the challenges we've made during the implementation of our solution. And then we're going to talk about micro frontends, again with a little bit of theory, sharing the challenges, and keep with that, the presentation will be very practical.
Yes, we have prepared a small application which currently is not very complex. It doesn't have much. We're going to slowly iterate over it, make it progressive, and then add micro frontends to it. And we're actually going to deploy several times, and so you can see it in action on my phone, which is here. Hope you can see it. Okay, and let's continue.
A little bit about our use case. About 2 years ago, we were tasked with a project and the deadlines were very tight. We needed to have a small to-non-learning curve. The app should be web-based, it should be cross-platform, cross-team mobile app, and it should have access to native services, for example, the scanner, the camera, etc. And that's why we chose to start with progressive web apps.
Yeah, just while Tish is talking, I'm going to simply go over the code and add some files, which we'll deploy and later on go over them as after they're deployed, and we'll show you what happens when you do it. Okay, so I'll do it on my computer. This one, yeah. Okay. Ooh. Wow, what happened? Sorry. Hello. Hey, excuse me. We lost. Yeah. Okay, there you go.
Okay, so why PWA? Progressive web apps are actually web apps that are enhanced with modern APIs. They're lightweight, very fast. They support offline capabilities. They are also very reliable and have applied features. As I said, you have access to the camera, for example, the scanner. For our solution, we have specific mobile devices that need to have access to the scanner, so we could scan specific barcodes, and we'll show you this in our demo project.
Just a moment. And just adding last. Okay.
Do you need us to zoom a little bit while this?
They don't see it. Okay, just a moment.
Okay, so currently Alex is deploying the demo. We're going to have an app that is installable. We'll show you using his phone.
Okay,
And
so
to make that, we need a manifest JSON file, a service worker. Alex will share more.
okay, before we move on, I'm going to show you what the current state of the app is right now. Open it. Before it's deployed. Now this is what it looks like. It's nothing. It's just two components. We'll put the MFPs here, the micro frontend. And if I turn off my internet, yeah, you get the gist of it. You don't have anything. Now, okay, so what do we need to make an app progressive? First off, we need a file called manifest.json. It's basically this is what we figured out to be the absolute backbone and what you need exactly. There are a lot more properties here, but we've just decided to go over the most important ones. And if you want to go over each of them.
Yeah, at the second line, you can see that we have a property called short name. When the app is installed, you will see it as a title. We have a description for our icons, and we have a start URL. This is actually the base URL, which the user will navigate to this URL when the app is downloaded and opened on your device. And when the app is opened, automatically is generated the so-called splash screen. It is a combination of the background color, the name, and the icons you have. And
yeah, generally when choosing what icons, you can put many icons here. Usually it's based on the operating system. On Android, for the splash screen, the icon which would be used would be at least 512 pixels, 512 pixels. And for the icon of the app itself, it's a smaller one. Currently, we just have a 5 icon which will be used for everything else, or at least everything here. So the 5 icon will be the app icon, splash screen, everything. Next is the start URL. This is basically the entry point of your application. Whenever you tap on the app, the browser needs to know it's open. So you can put anything here. But we just put the dots because we're starting from the root.
in your manifest JSON, you could also add some shortcuts. For example, if you double tap on your app when it's installed, you would have different options to be navigated to. But here we haven't included this in our example.
Okay, I think that's enough for the manifest. It basically just provides metadata for the browser so it knows how to install your app. And you just need to reference it in the head tag of your HTML, just like that. It's a special keyword here. Okay. The second and probably more important thing you need to have in order to make your app progressive is have a working service worker, which is just a basic JavaScript file. It could be basically empty and it will still work. You just need to register it at start. And here we have, I just added some, maybe it's too big. Can you see? Well, okay. Okay, so we've added some basic service worker, which uses a utility library called Workbox. It's developed by Google and it provides very nice utility methods for caching content, because in order for your app to work offline, it needs to cache its HTML, CSS, JavaScript, and so on. And there is this notion of pre-caching, in workbox, which basically means that whatever is built by your build process, so every CSS, JavaScript, HTML, every icon will be directly injected into the cache once your app is loaded. So you don't have to browse all of the files or reference them anywhere. They will just be automatically downloaded once the service worker is installed. And what's important to say about the service worker is that it works on a separate thread. And yes, this is an actual separate thread, no, not what JavaScript does. And it's per domain, which means that you can register one for the whole domain. It will control every app, every tab which is open for this domain. And it's the same for all. And what we've done here is that we have pre-cached whatever is in this workbox manifest file, which is basically a variable, which is basically just a variable specifying all the names of the built assets. And here we're just saying that everything which is served from index.html will be served from the actual cache. So whatever is in the cache for this HTML will be served from there. So yeah, you'll see it in action.
This actually makes the app pretty fast. But you should be careful when you decide what to cache and what not.
Yeah, here we've added some rules which do not require caching, because if you don't do this and you type /logout, for example, your app will never go to the actual backend where you want to allow from. What will happen is that the service worker will just return the HTML because it thinks that's just navigation rules from your React route or Angular route or whatever you're using. It just thinks it's from the single page application. So these are some common paths that we have. Usually login and logout, you need to not cache.
And something else about the service worker, they work under HTTPS secure connection, but they could also be tested on localhost. This is some exception. Your service worker won't be able to be registered if you have some syntax errors or if you don't develop under HTTPS.
I actually forgot to add something, so I'll add it now before pushing. Oh, not here. Just a moment. Let's register service worker.
Yeah, this is how the service worker is actually registered.
Yeah, we're using this service worker registration file. Don't bother with it. It's also generated by Parichkova tab, and basically you can write your own. What it does is it downloads the service worker after the app is loaded, and it registers it as a service worker. Okay, so I'll have to push this now in order to see the change. I'm sorry about that. Oh, oops. And it's just service worker. And
We'll need maybe at around minutes for
around 2 minutes for the app to be deployed. Okay. In the meantime, we can talk about what problems may arise when you're pre-caching. So I will go back to the time. Okay, we talked about this. Okay, so with callability, we said you need manifest and service workers. Service workers are basically web workers. Okay, we talked about manifest. Yeah. One major problem that we had when we were developing this over a year and a half ago, we didn't have any idea of progressive web apps, by the way, and we were just tasked with developing something mobile friendly. And one big problem with this is how you handle authentication, because generally, if you have a normal app and you browse the root of it, the browser makes a request to some backend which then serves the HTML. And usually this backend would have some sort of interceptor, and it would automatically redirect the browser to a login page. But in the case of pre-cached index HTML, this cannot work, because when it's cached, the service worker will always serve it from the cache. It will never make the request to the backend. So there is actually no logic which redirects to the login in this case. And this took us a lot of time to understand. And how we managed to fix it, can you explain?
So I'll dive a little bit deep in the caching strategies, and if we can go back to the code a little bit. Yeah, here you can see in the with the network strategies, please. Yeah. There was a part where we say to the service worker. Yeah.
This is it. Sorry. Okay, so with authentication, how we fixed it. So you have to make your own logic which redirects to the login page. I'm sorry. Yeah, so what we did is we made an endpoint on our backend which returns whether we have any session, and we call this when the app starts. And only after that we make subsequent calls. And if we don't have authentication, we manually replace the URL with the login page. And as you could see here, if the login is not cached, so it will safely redirect to it.
On line 20, you have all the URLs that serve the cached.
Yeah.
For example, logout, login, and everything that starts with API.
Okay, I believe that we have deployed. Let's see. Is that the one? No, this one. Okay, it is deployed. So if I go to my phone now and I refresh this page, after some time I should get a prompt. Okay, it's not working. Why is it not working? Okay, I should get a prompt here to
You can
on
see
the
it on
bottom. It says add product scanner demo to home screen. So this basically means that now our app is installable, and if I tap on this, it prompts me whether I want to install it. So if I click install, it's currently being installed. As you can see here, it should give me a notification that it's at the home screen. And if I go to my home screen now, I can see on the top left, there's my app.
Don't forget that you could always browse your app in the browser, and also use it installed.
Yeah, and what's nice about this now is that if I turn off my internet and I refresh, this will now be loaded. If I turn off the app, I turn it on again, install. So now you don't get the Chrome dinosaur. Yeah. Okay.
Yeah, this is thankful to the pre-caching Alex explained previously. During the installation step of the service worker, we pre-cache all our static assets, and that's why they can be served offline also.
Okay, so now since this app that we're showing you right now, it makes an actual call to another API to fetch user info. I can show it, but it doesn't really matter. I can show you the network tab later and what happens there. So it makes an API call, but this is not cached. It only caches everything you have built. So for API calls, which you want to cache on runtime, you need to define your own routes. Workbox doesn't do it for us. And you can explain while I'm writing.
Just a little bit about Workbox. It gives us a set of modules that help us working with service worker. It also helps us define some caching strategies. I'm going to explain what are the caching strategies that Workbox provides, and we could also add our custom caching strategies. For example, as Alex said, there is a pre-caching of static assets, but there's also a runtime caching. And thankfully to Workbox and the caching strategies which are Python, I'm going to explain this to you. we could also cache the responses we have. Workbox supports 5 caching strategies: cache only, network only, cache first, network first, and stale while we validate. So if we're using cache only, for example, the response will be from the cache, it won't go to the network, but to have this response, you should pre-cache it first during the installation step. If you choose to use network only, you will have a refresh response, but your app won't be working under offline mode. If you, for example, choose to work with cache first, when the service worker sees that there is a request from the app, it will intercept it, and if there is a response in the cache, it will be served there. If not, it will go to the network, it will return the response at cache. So afterwards, if you visit this app again, you will have the response. If you choose to go with network first, the response will be served from the network. If it doesn't exist for some reason, it could be served from the cache if it exists. And last but not least, stale while we validate. This is maybe one of the most complex strategies. Here, the speed is very vital, and we try to return as fast as possible the response. That's why it's served from the cache, but in parallel, a request is made to the network and the response is cached. And if you try to turn off your offline mode, you will have fresh content that is served from the previous response from the network.
Yeah, we're going to show some of those strategies with code. Now, first of all, Chrome provides a really nice way to inspect your devices. So, apart from my screen sharing, I'm going to also touch my Chrome browser and inspect what's on the phone. No, it's moved to my other screen. Okay. Wow. Okay. Let me just make it small. What happened? Okay. That's the next for you. Okay.
Now, thankfully to this application, tablet is very easy to debug your service worker, to see what's going on with the manifest file, to see what you have in the cache. You have different options you could use to test your service worker. Here, Alex is showing manifest and the service worker. Here, if you could see those checkboxes for offline, update on the world, and bypass for network. For example, if you would like to simulate offline mode, you just need to click this checkbox for offline and you will have your app working in offline mode. This is how you could test it easily locally. If you would like to have your service worker updated on the very moment you are registered, you could just check this update on the world option, but if you would like to test your app end-to-end, don't forget to uncheck it. And bypass for network is when you would like to get the content from the network and nothing from the cache.
And where is the actual cache? You may ask it here in cache storage. Maybe that surprised someone. Okay, but you can see these are all the build files that Webpack has provided for us. And they are cached. You can see how big they are, what their content type, when they were cached. And they also come with this, with this workbox revision. It says that this is just a hash, which is used to indicate what's the version of the file. So when you update the service worker and you introduce new files, it will automatically check what's cached and what's to be cached, and if there's a mismatch, it will update the cache to the newest versions. So this is why every file here has some sort of cache at the end.
In our case, it works together with Webpack, and this is actually the content hash. Every time, for some reason, the content is updated, you update it, or you have a new version of the font, for example, this content hash will be changed, and this is how you say, hey, I have new content.
Okay, so I wanted to, before we check how we can cache the user info that we talked about earlier, I want to show you what happens right now before we update the app. So if I'm online right now on my offline on my phone, and you can see that the user info just failed because there's no internet, it doesn't appear anywhere. So what I just pasted in the code is one of the usage of one of the strategies that Tish just talked about. It's very easy to define your own cache. You just have a root, and then you define a new root. This is all from one box. The first parameter is basically how you match the root. Here currently we're just matching whether it includes this root. You can add regular expressions and callbacks or whatever with different types. And the second parameter is the strategy we're using. So currently this endpoint, which is matched here on line 51, will be cached first, which means that once it's in the cache, the browser will always, the service worker will always return what's in the cache, regardless of whether there's network or not. You can add plugins to the strategy. Here we provided an expiration plugin, which means that this cache that we defined here will expire every day, basically. So once a day is passed, the cache will be invalidated, and the browser will see that there's nothing in the cache, and it's forced to make a request. There are other types of strategies as we talked about, but yeah.
Keep in mind that if you have something cached, it's a good idea to add some expiration date and timestamp, just to be sure that you won't serve any very old content, for example.
Okay, I'm going to turn on my internet now and go back to the DevTools. So if I refresh now and go to the console, since we deployed the new version, you'll see this console log, which is from the service worker. It tells you that new content is available and it will only be used when all tabs for this page are closed. Which means that in order for data to progress to web app, you actually have to reload twice. So the first reload will download the new service worker. It will still serve the old cache, but it will download the new service worker and check whether there's a difference and update the cache. So the second reload will actually now serve the newly cached content. This is something that we've had a lot of problems with this caching, because usually our end clients are very weirded, can I say this? So by this process, they have to reload twice. They're thinking what's going on, why isn't it updating, and that's the reason why. What you can do in this case is notify somehow your clients whenever there's a new version, and probably add some button which reloads the page, or does something which reloads the cache. So yeah, I'm just going to refresh again.
Keep in mind that one service worker controls a certain page. It has a scope, and for example, if you have two tabs open and one is with the old service worker, until you close the first tab, the other one won't work with the new service worker, so it will be in some kind of a waiting state until the first one is killed.
Okay, and you can see now our user info endpoint has changed. Now the request is resolved from service worker. It doesn't say the actual size, it just says it's in the cache. This is the initial call because we have to cache it, and it's later served from the cache. But if I refresh now, you see just one call to the service worker. It's been resolved from there. The app will not make any request to the internet. And in the application, where is it? Oh, Okay, you can see there's a new cache here, the name updater, and this is the user info which is cached. And in the app, it's usually the user info is here, just an email if you check on the web. And if I go offline now, I'm just going to show you how it's internet. And I refresh now, whatever was for the user info will be there. So it's just that. There's no need to go to the internet since it's cached. Okay.
And about this cache, if you see here during below workbox pre-cache and cache storage, you have this prefix updater. You can choose whatever you want. You can have different prefixes.
Yeah, this is just a cache name here.
Yeah.
Okay. Let's go back to presentation. Oh, wow. Someone was really angry. We talked about offline capabilities. We may talk about both queues, but only if you have time, we'll see. They basically allow you to store requests for later, requests which have failed. So if we're talking about post requests, delete requests, and so on, because these are all, what we cache now are just get requests. So if you want to save a request for later and retry it when there's internet, the workbox queues are very handy.
Keep in mind that if you would like to support offline mode, you need to also design your services to support it. It's not only on the client side, you should also design your backend architecture in a way it supports offline mode and to keep somehow some sequence, for example, the request you make if you have dependent request, for example.
Yeah, so in order to support offline, you need to have a proper backend. It doesn't work just one way or the other. So because in order to support offline, you need to have all the information on startup, which means your backend has to provide it. So if you're choosing this solution, you need to design a backend also. Okay, and let's move on to the second part of our presentation, which is Frontends.
Okay, so few months ago, our app grew, and we wanted to integrate it with other apps. We wanted to have same look and feel, and actually have just one app that is installed, and many functionalities are here to be used. And that's why we decided to go with micro-frontends. Alex can explain a little bit the technical approach, how is actually happening, what is, for example, container, what are micro-frontends, and we'll show you examples how to do this using Webpack.
Yeah, so I can move later to the next one. Yeah, so micro-frontends are a feature of Webpack 5 and above. They are implemented through the Module Federation plugin, and they basically allow you to expose parts of your app or the whole application to be loaded dynamically inside another application. This allows for teams which develop parts of the app and to deploy independently, and they don't have to care about what the other teams are doing. They can have their own storage, they can have their own backend if you wish, they can use different framework if you wish. It can be written in Angular, Vue, React, whatever you like, and you can combine them into a single app. What's also important is that usually there's one container application which is actually the HTML, which loads all the other small micro-frontends, because you have to serve something. You will see it later. I will now just add some code.
The important part about micro-frontends is that they are tool agnostic. You can have different projects, as Alex said, and different JavaScript frameworks or beyond. And also the project, the micro frontends, they are self-contained. They could work separately. They have a separate deployment pipelines and etc. And yeah, this is
just a moment, let me write this.
currently Alex is preparing the snippets we're going to explain in a few seconds.
Yeah, so while I'm writing, I'm just going to say what we did. So the app you just saw is just a container. Right now it doesn't have any micro frontends, so we're going to add them. And one of the projects is just a scanner. It opens the camera on the phone and it scans some. We have a few items here. If you're going to scan, show you how it works. And it's written in Vue, but as you saw, the container app is in React, and another application which is just will show how you can add a product, and it's written again in React. But we just wanted to show that there are different ways to you can use different. Sorry, I'm writing in fact.
Yeah.
Different frameworks. Yeah.
If you have progressive web apps built with micro frontends, you need to take into consideration that the service worker should be one, and it should be in the container app. The cache is also shared between the micro frontends and the container. And yeah, one service worker works for one domain. That's why you shouldn't make service workers with the different micro frontend projects.
Okay, I am almost ready. It may seem a lot, this not. Okay, so, oh wow. So in the app CSX, where we had the H1s we saw, the scan for the component calls here itself. We now have two new components, which are called scan products, and if you you go over to them, you can see that currently they are dynamically importing some module called scan product / scan product. Where is this module coming from? It's not an npm package. It's not installed. It's not something we define. This will be fetched at the runtime whenever this component is mounted. There are different ways of doing this. Right now we've chosen the easiest way, which would be just using dynamic import. You can use React Lazy and React Suspense if you want to show some loaders and so on. Yeah, and I would have done the same for the product. It's basically the same, just a different name and a different module. And if we go to Webpack config, this is the configuration that you need on the container side. You have a name, you have the remotes. So if you saw it earlier, this was the module. This was the root of the module, scan product. And here we have some. It imports this name from
the export.
Yeah, from here, from /js.demo scan product. Now, the other application is deployed on a different domain in general. This one is on the same domain, the other one, the app product, is on a different domain. Just wanted to show you that you can add a fully qualified domain and it will still load them. These names here, they are defined in every micro frontend. So if we open the other one, for example, this is the app product one. I'm going to hide this one, sorry. Yeah, you see this exact same name here. So this micro frontend is defined by this name, and this is the remote entry. It's just a file name that will be exported, which will have to be the same name which we import from. So if you go back to the to the container, you have remote entry here. So that's just naming convention. You can name it as you wish. And here you have to define what this microfrontend exposes. Currently, it exposes this file. Just if we open it, it exports a mount function.
You can export different parts of your project. In our case, we have exported the whole application, but you could expose different components separately if you would like to.
Yeah, and if we check, for example, the output, that it does exactly that. From the import, it expects to have a mount function. This creates some coupling between microfrontends and the container, but that's pretty much inevitable. We have to know where it's located. Okay, let's deploy it. Oh, good. One thing to note here is that, as Tish said, since those applications are loaded dynamically inside the container, they share the same service worker, which means they cannot define their own. And this means that you have even more coupling, because since they're dynamically loaded, they're not pre-cached by workbox. They're not part of your build process because they are imported on runtime. Which means we have to define our own caching strategies again for them. Otherwise, working offline will not be possible because they will simply fail the request.
And if you don't choose the right caching strategy, you could end up with some stale versions of your micro frontends.
Okay, deploying. We'll just wait a bit for it to deploy, and we'll see the microfrontends there. Come on, you do it.
You could always choose to go with separate NPM packages, but there are some drawbacks. For example, if you choose to have one up as a container and export your project as an NPM packages, you would end up, in case you have some code fixes that you need, you have some support incidents, you code fix, and that's the graded version. You need to also update it in the container, and you will end up with more time waiting for the deployments, both in the micro frontend and the container. So that's why we chose to stick with module federation and Webpack.
Okay, so now it's deployed. Remember we talked about the refreshing. So the first refresh shouldn't do anything. As you can see, nothing happened. But the second refresh, now it's loading our MEP. There you go. We don't show a loader because we didn't think it was necessary for this presentation, but now we have the microfrontend. So this box here, which is the text and the scan product, this is not part of the container. It's exactly entirely inside every project. And I can try to scan something. We have some cheapos here. Let's see if the lighting is good. Come on, man. Yeah. There you go. Woo! Okay.
We can try to add some product or...
Yeah. Okay. See, now it's loading the other microfrontend. It didn't load it prematurely. It waited for us to actually go to the other route. But once it's loaded, it's there. And yeah. What happens if you go offline though? Now there may be it may be loaded now. No, it didn't. Oh wow. Okay. Okay. No, it is taking Yeah, now it's loaded because it's in the memory cache of the browser. Even though I don't have internet, but that's not very reliable cache. And it will be here in, I don't know, 15 minutes or an hour or whatever, whenever, in a day, which is not very nice because in a while we will lose this, even though we now can see it. We can check the, reconnect, can I reconnect? Okay. Just a moment. I guess I opened the new application and this was lost. I just wanted to show you what happens to the request for the Model Federation plugin. If I refresh now, you see that the remote entry for both file. Oh, sorry. And as you can see, this is served from the disk cache, it's not from the service worker. And at some point, this disk cache will okay. So how do we make this always offline first, offline capable? Just like we did with the caching of the user info, we need to do the same with the caching of the remote entries. So if we go to the service worker and we type in come on. Nope. There you go. Cache. So here we're basically doing the same thing as above. We're just using the network first approach, which would mean that if there is network, the browser will always tend to fetch the latest version of whatever is matched on line 68, yeah. And this is because we want to always have the latest version. Depending on your implementation, you may want to have it cached for a day, so it's always from there. It's up to you. But if there is no internet and there is a cache, it will load it always from the cache. I'll just start it now and deploy it so we can see what happens. Here we're also caching this product query. This is a query which we make so we know what products we have. As I mentioned before, you need to have a backend in such a way that it holds all the information prior. And this is how we cache that information for offline use. And after it's deployed, we'll show you that this will actually work offline as well. The scanning. Yeah. Sorry about the delay, it's just that we want it to be more interactive. So we are deploying in front of you. We'll have to wait for a minute or so. Okay. Okay, so if you want to have a real offline experience, you would also want to be able to update the cache. So imitate a successful backend call. Let's say, let me open up my phone again. Let's say we go to the add product. This is just a form which adds a new product. It's very basic, don't think about it. And if we're offline and we click the confirm button, the request will fail, definitely. But what you can do is imitate that the request has succeeded. That's up to you and your implementation if you want such functionality. I can try to do that now.
What is going to work with this one?
No, I do. Now I'm offline. I'm going to add this M&M and try to scan it later. And it doesn't exist in the products prior, believe me. Okay, so it's fine. Let's hope I wrote it correctly. Yes. And of that. It weighs how much is it? 45 grams. No. Yeah. 45 grams. And I can even take a picture of it. Great success. Now, if we click the confirm button, since we're offline, it tells us that we have succeeded, but we haven't actually succeeded because the request has failed. If we check the dev tools, see that has failed. But we're tricking the app to think that it hasn't. And if I try to scan it again, now, see if I can succeed. Come on.
Hope you have written down the barcode correctly.
Yeah. If I haven't, then we have a problem. Now I have a lot of problems scanning this. The library we're using is third party. Didn't like it. Come on. Don't fail me now.
Yeah, it's very specific because you should be aware of the light and
How did I do it at home? Okay. Well, sorry, but we won't be able to do it. Yeah. I really wanted it to happen.
those others and the light demo.
Yeah. But essentially, you should have been able to see what we just added and see it in the form. I can show you what happened to the cache because you can see that it's updated. In the app data, there should be one more. We didn't add this. No, should have done it. Oh, no, we're not caching it yet, so that's why it doesn't work. Okay, we're going to show it to you later. It should be deployed now. Sorry about that.
Currently, what we've done, once we made the request to add new products, we just get what we have, products from the cache, and add this new product, in this case M&Ms. And this is how it works. Of course, there are other ways to do this. This is just for the purpose of the demo to demonstrate how it works offline. There are so-called queues and background sync, which we're going to explain if, of course, we have enough time to do it.
Okay, just to say, after the deploy, you can see that the remote entry is now fetched from the service worker. Oh, yeah. And the products which we're attempting to update, and that's why it doesn't work, are now cached. So if we go back to the application, here you can see there's a lot more things now. You can even have the products now.
Yeah, you could demonstrate how many products we have currently. We have
9. 10, I mean. Starting from 0, of course. Okay.
That's programmer.
So I will turn off the internet again and try it again.
Hope this time it works. Okay, so I'll just take an M&M's and leaving 45 and oh, thank you. Okay. Now we don't have internet, as you can see at top, we confirm. Okay. That's
successful. And now try it now.
Hope it works.
There you
it
go.
works.
And if we check the cache, here you see that there's an 11th item added, which this microphone that has added. Yeah.
Yeah.
This is the M&M.
Yeah, with the image, the name, and the weight.
Yeah. So, yeah, it's possible to update the same cache from a different application. It's generally, I don't think it's a good practice because currently this, the app product, MEP, like Frontends is not the owner of the data, it's supposed to export, to actually notify the container whenever it has added the products, and in turn it should notify the other application, so it's updated its cache. But for the sake of demo, we have updated the cache directly from the second on my front end. Okay, yeah, this now works offline, and we have 5 more minutes. I think it's enough for us to also show you the workbox queues, but we won't have time to go over another code because it's a lot. So we mentioned earlier about how do we manage post, get, patch, reads, and so on, queries. So I'm going to add the background thing. It's a lot of things. So what the workbox gives you is also a way of storing failed requests, so you can try them later using just queues. It's called a queue. There you go. You create your own queue with a name, and whenever a request which you have pushed in the queue fails, for example, we do it here. On every fetch, we check the method and the URL, and we push in the queue if it fails. So whatever is pushed there is actually in the IndexedDB inside the browser. We will show that later. And we have also added a loader which should show you how the requests are made after the form comes online. I just need to quickly add some code.
Yeah, again, the queue has some retention logic. You could choose for how much time you would like to store your data. And once the data is consumed, it should be cleared.
Yeah. Let's then push again. Okay, so what we can go over the code quickly. So in the service worker, we define a queue, here the background C queue. And we also define a callback, which is what happens when you sync. This callback will be called whenever the device comes back online automatically. And what it does is it tries to shift from the queue. Don't mind notify client, I will explain it later. It attempts to fetch the original request again, and if there's an error, it adds it back to the queue. So it tries to just empty the queue. If it fails, it will bring it back to the queue. You may notice there is a function called notify client. This basically goes over all the clients of the service worker. In this case, these are all the tabs. And it tells them that something is happening. And it just tells them, if you just write post message and you add some message. Currently this would be some JSON. And in the app layout, we attach here, whenever the navigator service is ready, we attach a callback on message and we expect some messages. So whenever notify client is called, this function here on message will be called, which here it just updates some local states so you can see the loader. And you see what that allows us to do. If this is deployed, come on. I need to talk more than. There you go. Okay, so let's go back to my phone. Turn on the internet because we need to fetch the latest version of the service worker. Reload once, reload twice, three times to be lucky. And okay, so what this allows us to do now, if I turn off my internet, I will just run this form several times with some more data. Let's say 24.5.
You will just add those products to the queue and see how the data is consumed.
So I will click confirm. Let's write 7, 48, and picture confirm again. 9, 30, confirm. I'm just adding some queries so that we know, so that we can see the loader. Okay, so I added 4 or 5. If we go to our, if you go here, you can see the network tab and see the data load failed. And that's expected because we don't have internet.
And
But yeah.
now if you go to application and navigate to IndexedDB, there should be.
Yeah, there's the background sync, and you can see all the queues requests are here. They're just waiting for internet to come back on and be resolved. Okay, so I'll come back to scan product, turn on my internet, and we should get, hopefully, a loader, which we didn't get for some reason.
Try to load it.
Okay. Live demo, man.
Okay, so I think that they're consuming. Oh, can you navigate again?
No, they're still there. Okay, so now is the place to show you how you can actually run your own sync. It should be working. I'm not sure why it's not trying, but you can basically from here you can run manual sync. If you just write box background sync column and then you write the name of the queue. Our queue is in background sync, so that's the one. And if I try to sync it now,
Yeah.
you see the loader here appearing. Now it's retrying the queries now. If you see the network tab, yeah, it's returning 413 because we probably did too many queries to our API. But it's currently trying to do that. You can have your own logic, but you can see that it's attempting to sync. You can also have your own logic, which does a background sync every minute or every half a minute or so and so on. But yeah, that's what I want to show you. I'm sorry that we couldn't fulfill those queries automatically, but that's usually how it works. Of course, for the demo, it won't work. Yeah.
Actually, one feature that we didn't mention and don't have focus on today is the push notifications. We could also add some logic for push notifications if PWA supports it.
Okay. This is just a link to the app if you want to click on it.
You can scan it and your app will be installed on your device.
Okay, so that's all the time I have today. I hope it's been interesting and so you learned something. Again, this is a very niche case where you have micro frontends and progressive web apps working together, and it's not a to-do or how to do something. It's based on your business and need. This is just what we needed. And thank you for attending. I guess you're very hungry at this point, so you'll want to